Okay, here's problem 8, which sort of piggybacks on problem 7 from Stallings Wireless 7.8. It says to find the cross correlation between channel 0 and all the other channels from problem 7.7. So here I've taken the channel codes and drawn them out as pluses and minuses for channels 0 through 6. And here you can see very clearly the fact that each channel code is just a shifted version of the previous channel code. You can see these 3 pluses and then the 2 minuses sort of marching off to the right here and wrapping around. So here they are. And the cross correlation, basically you take the 2 codes, the A and the B, and you multiply them bit by bit and then sum the result. Okay? And that's the cross correlation. But this depends on tau, which is the offset of the 2. And the whole thing is normalized to the length of the code. Here n would be 7. But we're going to ignore the 1/7 in this problem. I'm just not going to multiply by 1/7 at the end, in other words. And what I'm going to do then is I'm going to take the tau equals 0 case. This is a little bit different than I did it on the board the other day, by the way. I'm going to take this tau equals 0 case for each cross correlation calculation. So I'm going to put channel 0 and channel 1. I'm going to multiply them. Okay? It's kind of like an XOR when I multiply plus 1s and minus 1s. And then I'm going to sum them. And I get a -1 when I do a cross correlation between channel 0 and 1. I get -1 for all of them, as a matter of fact, until I get -1 for all 6 of them. However, if I correlate channel 0 with itself, I will get a 7. Okay, and so that's what happens. So if we do look at other tau values, tau ends up shifting one of the sequences relative to the other. Okay, so it's simply misaligning the sequences, but we already have our spreading codes are just shifted versions of each other anyway, and so if we look at the other tau values, all the results will be -1 except when the patterns line up, in which case we get a +7. And that was demonstrated on the board the other day. So that's this problem. And the idea here is that in a CDMA system, we're assuming that that we do have alignment of the 2 codes. And the idea is that we only get a good cross-correlation function that is a large value of cross-correlation when we use the correct code, basically. Okay? So that's problem 7.8.